Good afternoon, everyone. My name is Chirag. I'm here to present to you a presentation called, which has the title ServerSide Steroids for your Flutter app. A quick introduction about myself. I've been doing mobile since the last 4.5 years. I've done close to 8 Android apps, 2 iOS apps, and then I've been doing Flutter since the last 6 to 8 months. I work as a mobile engineer at ShareChat, which is India's largest multilingual social media platform. So you can think of it as a Facebook in all regional languages in India. So we have around 16 languages the app supports, which has over close to 100 million downloads on the Play Store. Apart from that, I like trekking and photography, so that's just a quick introduction. Okay, so what is this talk all about? If you can see the title, it says steroids for your Flutter app, server-side steroids. So it doesn't have anything to do with steroids, of course. It's your whole app being controlled by the backend. So what this means is your entire app, ranging from your the screens that your app has, the kind of layouts that your app has, the kind of requests that your app is making to the backend, all of this is going to be controlled entirely from the backend, right? So theoretically, there shouldn't be any hard-coded logic on your client at all. So say you have a login form. What if there was a way to completely eliminate all those logic of, say, building a form on your front end? What if everything was controlled from the backend? Like, I need to ask the user his name and email ID. So tomorrow I need to ask his phone number as well. What would usually happen in this case is you would probably make another app update and you would add another form, another field to the form saying, okay, I need your mobile number as well. So is there a way where we can try eliminating this and making the app completely driven from the backend? That is what this talk is about, and the idea behind this is making the mobile client a thin app, right? Thin client. So this is kind of inspired from the web technologies where your browser is a dumb interpreter and it just interprets HTML and some sort of a markup language. Is there a way where we can do the same concept, a similar concept at least, using Flutter on your mobile app? So what this could essentially lead to is almost no updates. So we'll get to the almost part a little later into the talk. But think of it as a way where we can push updates over the air. Like using the server, you can just update your app. You can build new screens. You can build a lot of new stuff without any app updates, right? So that would be a really cool place to be in. Because the problem with updates is a lot of users do not update their app very often, especially on Android and in a place where there's not much of internet connectivity. People usually turn their automatic updates as off, and then you might still have some people using some sort of your client which was very, very outdated, right? So that would be a very tricky situation to keep supporting all clients from a very long version. So that's the idea of it, like try to eliminate app updates as much as we can. And why do we need this is something we will try to address before we start how we do this. Okay, so this essentially is a list of all the things that this approach is going to help you. So let's start off with the most coolest thing, new features on the go. So as I said, say you want to build a new feature in your app. Say there's a new sort of flow where a user has to create a post or create something on the app. So what if there was a way where we can do this entirely without an app update? So that's what new features on the go means. Customizable layouts. So what I mean by saying customizable layouts is, say we have some sort of an iPad and then you have an iPhone as well. So is there a way without hard coding anything on the client, without hard coding two logics of orientations of the client, is there a way where we can have customizable layouts for both of these devices having different screen densities, different screen sizes? And then there's easy A/B testing. So say your client or your product manager wants to know which color of a button is having more CTAs, right? How do we do that? So the way it generally works now is there's a flag being sent from the backend, And we have sort of a A/B test mechanism where it says, if true, then the color is red, if or else it will be some white or something. And then you analyze the metrics accordingly, and then you do your A/B test. So even this can be completely eliminated. So we can have even say the colors of the buttons, the size of the buttons, everything controlled from the backend. And the next very interesting thing that we also were able to solve using this was bug fixes from the backend. So say there was some bug in your code, and instead of having a quick fix or a release just after your main release is done, just because there was a small bug in your app, is there a way where we can completely eliminate that as well? Yes, we have been able to address that. And this also helps a lot in reusability and standardized UI. We'll get to these points a bit later once you understand what this talk is about. Okay, so what is not server-side steroids? Let's start off with that. So since this is a social media platform, you can see a screen where there's some sort of a necklace. It's a post, basically. It says an elegant jade necklace. And then you have some sort of action items at the bottom, which the first one is a WhatsApp share. The second one is a comment. Third one is a like, and so on. And there's an image, and there's a username, and there's a handle associated with it, and a profile picture of the user. So in your typical mobile apps right now, what happens is you probably would be having some sort of API response that you see on the right side. So you can see a post object in the JSON, and then you can see an author inside it, and then you have a username, a description, post type, and so on and so forth. So this is probably the standard sort of API responses that most of our clients are able to consume. So once you get this API response, you would put the description into its proper text or whatever, and you would populate all your views based on this API response. That is the typical way. So let's see, what does server-side steroids mean. So instead of having data coming like the one which we just saw, what if there was a way where we can have each section of the post categorized into different components, if you can say. So the first, you can see on the right side, it's the author component. Then you have a description component, then you have a post content component, and you have a buy component and action components. So instead of the traditional way, what if we can kind of categorize or make it into different sections, like think of this as a complete screen. It doesn't have to be a post. It can be a complete screen itself. So you're kind of making this into different components which can be reused as well. So that's where the reusability comes. So for example, if you can see the topmost header, right? It says username, flare, and it has a profile photo. So if you wanted to use the same component elsewhere, we could do that as well. Yeah, so your API responses are going to be completely different in this sort of an approach. It's not going to be the regular way which I just showed you. And of course, all these components can be plugged and played wherever you want. And the interesting part about this is, how do we do this? Yeah, so there are many ways to solve this actually. I think Airbnb has been trying to do this as well. There's an Indian company called Flipkart which also has been trying to do this. And this is our solution that we came across at a company. So the front end, we're using something called as a component-based architecture. This has nothing to do with any sort of standard state management systems that Flutter uses, or some sort of architecture which Flutter proposes. This is completely built in-house to cater a solution that works for us. And the backend was using Node.js, so that we will not be covering that part in this talk, since this is more of a Flutter conference. And why we chose Flutter was, of course, we would have access to Android and iOS immediately. That is the most obvious reason. The other reasons were things like the very basic feature of Flutter is that of a declarative UI. So we could have done this in Kotlin, or we could have done this in Swift, but it would be much harder to inflate views dynamically all the time, inject views into other views all the time, And we thought that the declarative way in which Flutter builds things is very easy, and it also, since it also relies more on composition, we thought it's a really good solution to use Flutter for this problem. Yeah, so the way we kind of do this is similar to how HTML does. So HTML has its own, it's a markup language, right? We try to have our own markup language that we built from scratch. So what happens when you try building a grammar? You would probably need some sort of segregation of what all things that your app can represent at one time. So think about any Android app or any mobile app for that matter. You can broadly classify the elements of the app into these 4 building blocks, or I've called it as components in this talk. So they are basically UI elements. So in UI elements, I mean things like buttons, lists, check boxes, anything that you see on your screen can be classified as a UI element. And then there are methods or functions. Let's call them as actions in this talk. And then there's something called as entities or domain models. So these entities or domain models are basically blueprints of what your data is going to look like. So if you have, say, something like a student class, that would be called as a domain model or an entity, and its properties would be things like age, name, gender, and so on. So that's what a domain model is. And then you have something called as resources. This is again taken inspiration from Android, where you have strings, you have colors, you have assets, and so on. So most of the apps can be classified into these 4. I mean, they will consist mainly of these 4 components. So the most important thing is what I've highlighted at the top. It says JSONs should be able to represent Flutter components. So is there a way where we can represent all of these 4 components using JSONs? Okay, that's the challenge that we want to solve. And for that, we are creating our own grammar. Okay, the way we did that was we used something called as a lookup key. So it's just a fancy name for a unique identifier, right? So even if you see HTML, it has tags, right? It has tags like head, title, h1, h2, and so on. So you can think of these as some sort of lookup keys or unique identifiers. We have called it as lookup keys. So in our case, it's slightly different from HTML, since we kind of have variations of the same element. We'll get to that a little bit later. And this unique ID, it's a combination of a path and query which defines every Flutter component uniquely. So in this previous slide, I had showed you there were things like UI elements, methods, entities, and resources. So is there a way where we can identify each of these uniquely using, say, a sort of path or query? That's what we're going to do. This lookup key or the unique identifier, we broke this down into three parts, right? So the first part is the component type. This would mean things like whether it's a UI element or it's a function or it's an entity or resource. These are the 4 things that you just saw in the previous slide. And then a component name, and then variation of that component. That's basically the customization of that component. We'll see a few examples of this a little later on. And then we have a parser. So you have a grammar on one side and you have a parser on one side. You just need to hook these 2 up. And that would probably create some sort of understanding between these 2 is what we wanted to do. So if you see here, what we do is we have a JSON with a lookup key, which is the unique identifier. We give it to the parser, which we built, of course. And the parser internally is able to decode that JSON and translate it into Flutter components. So as the diagram represents, you give a JSON with a lookup key to the parser and gives you widgets, functions, entity, and resources. These are the 4 building blocks of any app. This is a small example that I've taken. We have just used @ at the beginning, so you can, we're kind of creating some sort of a semantic for lookup keys. So that is just convenience for us. So if you see the lookup key, the example over here, the orange part is basically the type of Flutter component, whether it's a UI element or a function or a resource or a domain entity, right? Domain model. So that is what it represents. The second part, which is highlighted in yellow, it says name of the component. So UI elements can be, of course, of many types. It can be an image, it can be a checkbox, it can be a list, it can be just text, it can be a row, it can be a container, and so on. And the third part, which is in gray over there, it's a variation of that component. So it says image 72 rounded. So this means that this whole lookup key would translate to a UI element, which is an image. And the variant of that image is 72 rounded, which is something that we have created on our own, which says the height and width should probably be 72, and it should have rounded corners. Yeah, so these are the, like in the previous slide, you could see that it said UI element image 72 rounded. So on the right side, you can see that we have created a JSON with image as one of the objects at the JSON at the top. And these are all the variations of that image that we have used in our app. So what this helps us to do is, it helps us to standardize what all are types of images that we want to use. So say for icons, you want to use image with, for example, say a height and width 12. So you can see in the first example, on the right side in the JSON, it says image 12 and its height and width are 12. And on the left side, you can see the examples. Like it says @UI element image size 30. It represents an image widget with the variation of its size being 30 and 30. So if you can see that for each Flutter component, Flutter widget that's out there, we can create all its variations as well. Say it's a row. We can have a row with different different variations of the row, different alignment across its axes, and so on. A little bit into how we built this UI elements. This is kind of tricky for us in the beginning since we had to convert your JSON into understandable data which the Flutter SDK can use, and then give out actual Flutter components to render on the screen. So we kind of broke this solution into two parts. That's a layout and a drawable. Let's see what those are. Yeah, before that, we have another term that we used, which is atoms. You can think of atoms as the smallest particle that our app uses in terms of UI at least. It says atoms represent basic visual Flutter widgets. So all your examples that are out there are these are the smallest particles that your app can use, like a button, a row, a column, container, and so on, a text field. And multiple atoms can be combined to build a UI component. Well, I'll show you what that means. So if you remember that example which I showed you, it said in the post you saw at the top there was an author section, right? An author component. So an author component can be built using smaller atoms. So you can think of multiple atoms being combined to make a bigger sort of entity, and that entity we call it as a UI component. And this author component just takes a user entity itself, a user domain model itself, and it knows that it needs to put its text in at the top, which is the username at the top, and the handle at the bottom. And it knows that once you have an author model, you have to put the image at the left side in the image spot where it shows the black and white squares. So here you're kind of tightly coupling two components which are going to be reused throughout our app, right? So this author component, it can be reused very easily now. All you need is to have an author component and an author domain model. You combine both of these, and then you have this author component that can be reused. Yeah, a little bit of code here. As I said, we had two parts of the solution. One was using a drawable, and the second one called as a layout. So you can see that these two are very closely attached to each other, and let's just go through the two phases of how you would actually render a Flutter widget, right? So you would be building the view tree from the layout file. So the layout file, what it does is it takes the JSON and it kind of populates whatever data that is required to be sent to the drawable class. Okay, so you can just think of it as a pre-step before actually rendering a widget. So there needs to be a way where you can get data from the JSON and attach it to the actual Flutter widget, right? And then the rendering the view tree, it's actually done in the drawable. Like it says there, the drawable class is used to build native Flutter widgets. And you can also see there's something called as an element ID inside the base layout, right? So that is basically the lookup that we use, the unique identifier. Each base layout has its own element ID, and that is what is used to render the exact variation of that Flutter component. Yeah, so if you can see this slide, I think things become a lot more clearer, since you can kind of translate how a JSON would look like and how the actual Dart code that would get compiled would look like. So the element ID, the one which I just showed you in this previous slide, so that is at the top. It says it's a UI element with a column and main axis as center. So if you see the Dart code on the right side, it corresponds to exactly the same thing. It corresponds to a column with main axis alignment as main axis alignment center. So this is exactly why we chose Flutter, because it's a very declarative UI, and you can see that everything can be mapped as is, right? So you can have something like a children as a key inside your JSON, and then you have a list of children inside them. Each children or each child actually has its own UI element and its own sort of dependencies on other things. So you can even have images coming from other places to this place. Like if you can see on that line where it says image lookup key, what it does is that image view, that image Flutter widget is going to a place called resources, images, and profile photo, and it's populating that over there. Yeah, so I know there's a lot of code even on this slide, but this is how we have a container. If you want to have a container and you want to customize a container completely from the backend, right? So in this example, I've just taken as the color being completely customizable from the backend. So if you can see on the left side in the container layout at the top, it says base layout as a child. So each container layout most likely is going to have some sort of a child inside it, right? So that is what that means. And the second thing you can see is it says a color lookup key. So what we're trying to do here is we're trying to get the color completely from the backend each time. You can, of course, extend this to a lot of things. Say you want a padding to be applied from the backend, a margin from the backend, some sort of box decoration from the backend. It would be completely done in this way. For a simple example, I've taken just color being populated from the backend. And if you see that there's a small highlighted orange box at the bottom, it says if child is not equal to null, then the container's child is child.inflate. So what this does is once you send a child object into a container using a JSON, it recursively keeps inflating all the views that are there inside that. So if you see this the container layout on the left, it also has an override method which returns a future of base drawable, which is inflate. So that inflate call recursively happens to all the children inside it, and all its children's inflate method also gets called, and that's how you can have multiple widgets nested inside each other. And on the right side, you can see that that's a drawable file where we are actually doing something called as a render widget. If you see somewhere around the mid, there's a render widget call that's happening. And that is where the actual building of the Flutter widget, the native Flutter widget is happening. There's a return container widget where it actually returns the container back to whoever is calling it. And you can see that all your customizations can be done inside the drawable class. Like there's a one-to-one mapping of all the Flutter native Flutter properties of the drawable. So in this case, it's just a background color that I've used. You can also do things like height, width, padding, and so on. And in the bottom, you can see there are two functions for each of these. It says container.fromJSON and container layout.toJSON. So that's where the transformation is happening from your Flutter objects to JSON objects. Yeah, and this is how we have a parser that I told you, right? We have a parser which is going to convert a JSON to a layout. So if you can see this method called as layout from JSON, what it's returning, it's a base layout, the same layout that we previously saw, and it takes a JSON as an input. So if you can see that what it says JSON dot, if it contains this element ID key, what we try to do is we try to decode that lookup that we just built, right? So we built a lookup key, which is the unique identifier. And based on that lookup key, this parser is going to take out the JSON's exact element that it's required, and it's going to return that. So that's how you would convert a JSON to an actual Flutter widget. And then there can be complex layouts as well. So a very interesting part is, since we didn't want to have any hard-coded logic on the client, even things like if-else statements, right? That also became a layout now. Since you don't want to have any sort of hard-coded values, we built an if-else as a different layout itself. So think of if-else as a new Flutter widget for us now. That's what we had to do to make this app completely controlled from the backend. And even things like stream builder layouts, because we wanted to observe changes in domain entities, and changes had to be propagated in multiple places. We had to build stream builder as a separate widget itself. And you can see this is how a screen is now represented. So it says it's a home screen, and it has an app bar layout, and it has a body, and it has its own children, which is in this case the child inside. It says that it's a UI element with the Flutter component as text, and the variation of it. The style that we're using is black light 12. So it means that we would have created a variation under text, like just how I showed you with image with size 30, image with size 72. We have created something for text as well, which is black light 12. And there's something called as text lookup key in terms of for an image, which says that the text that needs to be populated inside this text field is going to be resolved from resources, strings, and hello. So in our JSON, we would have, in our strings JSON, we would have something called as hello as a key, and it would have some value. So that value gets replaced inside this text view. Yeah, so extend the same concept to resources. So we just talked about UI elements now. Now you could do the same with resources. You could do the same with entities as well. And this is how your lookup is going to look right now. Now that we can represent our entities and resources as JSON, we can create new lookups for them as well. So your @resources string hello would now resolve to hello world. So if you can see this example, strings hello would resolves to hello world. And even things like the last one, the third one in the row, which is entities, logged in user, and name. So if you can see the entity here, it has a logged in user as an object, and it has name as one of the keys. It would resolve to Chirag Shenoy. So this way, resources and entities can be referenced in UI elements. So that's what we're trying to do, right? We have UI elements, we have resources. This is a way to combine both of them so that we can render everything dynamically. So another problem that we had was how do we deal with button clicks, network calls, and navigation? Since I promised that everything is going to be controlled from the backend, even this is going to be controlled from the backend. So we have another term that we have, like actions or methods, you could call them. These are basically events that occur during the life cycle of an app. So things like navigating to new screen, making a network call, storing data to the database, showing bottom dialog sheet, all of these, they can also be represented as JSONs, right? So think of it, if you want to make a network call and you have some sort of a URL, even that can be controlled from the backend. Like since it's only going to be a JSON at the end of the day, we can dynamically change which endpoint you're going to be hitting also. So more example of actions would be downloading files, analytics, displaying dialogues, and so on. So just how we converted our UI elements from JSON, you can also convert a JSON to these actions that we have. So launch page, dismiss keyboard, these are all the same actions which I just showed you in the previous slides. All of them can also be represented in terms of JSONs, the same way we did for UI elements. Yeah, so in most of our apps, there are usually more than one action that happens together. It would probably be things like, say the user typed an OTP on the screen and clicked on submit OTP. So there will be usually a set of things that happen at the same time, right? It would probably hit our backend, validate the OTP, and once you get a response, you would go to the next screen, or you would show an error based on whether the OTP entered was right or wrong. So you can chain these actions together, then that forms a command. So in this example, there are two actions that have been combined. So the first action, it says get location, and the second action says do a post request. So you can change, and you can either run them parallelly or in a serial manner based on the requirement. Yeah, so again, converting JSON to action it's the same thing that what we have done. Oops. Yeah, so commands. So if you can think, why do we want to use these commands? So commands are mainly attached to UI elements, right? So say a UI element would be something like a gesture detector to handle tap events. So when the user clicks on a button, there needs to be a set of actions that need to be executed. The same example you can take, the one where you click on a button and then you have a network call being made, and based on the response of that network call, you could either show an error or you could go to the next page. And this is where everything starts to get truly dynamic, because it says, since commands are also represented via JSONs, the server can dynamically change the actions inside, thus making every button completely configurable. So say you don't want to make a network call on the OTP button again. You can completely easily do that right now, since your server is sending a set of actions as well, right? In this commands, the server doesn't have to send the first part, which is the first action, which says post request. You can directly go to the next page from now. That's how it gets completely dynamic. So you can go bonkers on this basically. And how do we connect these dots? How do we put these things together? This is sort of a high-level architecture that we built. So it's basically inspired from the repository pattern which Android uses. So what happens in this? Let's start with the repository pattern and the network service, right? So what happens is your repository would probably request some data from the network service, and it's basically making network calls, API calls, and you're getting something called as a DTO. So DTO is just a terminology that's called a data transfer object, which is what gets transferred over the wire. It's a JSON, and it's the same lookup key and it has the same lookup key that we have been talking from the beginning. And that DTO is persisted in something called as a data access object, which is the DAO pattern in Android. And it's basically some sort of persistency mechanism that we have used in order to cache data completely. And so this app would completely work the same even in offline mode. So though it's completely server-side driven, it still works exactly the same way in offline mode as well. And then you have something called as an orchestrator, which kind of connects all of these pieces together. It takes the DTO and it sends it takes the lookup from the DTO, which is it takes the lookup key from the JSON itself, and it sends it to a parser, as you can see. And that parser transforms that lookup key into components. So we've gone through many slides where the the lookup is being converted to an actual component, right? So that's what an orchestrator does. And it gives back those actual Flutter components to the UI layer, which renders it. And the UI layer can also send lookups and get back components. That's like a high-level architecture that we have over here. This is how the working would actually happen. For each screen, we have a GateScreen API call to the backend, which returns all data required for that screen. And guess what? The response of this API contains the same 4 components that your app needs, the 4 building blocks that I've been talking all the time. Your backend would send the same 4 stuff for each and every screen. So each and every screen can have different UI elements, different commands, different entities and resources. And based on things like what data the client already has, it would send, the backend would kind of maintain some sort of a state and return only data what it requires. So we're kind of minimizing transfer over the air as well. So we have kind of optimized even that as well. Yeah, so these are the 4 elements, 4 basic components that your every screen would require. So it would require its own UI elements, its own commands, entities, and resources. So since all 4 of these are coming completely from the backend, you can change any one of these at any point of time, and you're kind of bypassing an app update. So say you don't want to make a network call anymore, you just don't have to send one of those commands inside, one of the actions inside that commands. Say you want to show some sort of a different entity, you just have to change things inside the entities section. Say you don't want to show some sort of header, you want to change that header dynamically from, say you want to do something like a hard-coded value like purchase, you want to change it to buy now, just to see how things are appealing to the user. You would just change that under the resources section, and your app would just pick up the latest values from this and display that. Yeah, few positives. These are basically the advantages that we have got. All layout screens, HTTP requests are controlled by the backend. So we've been discussing this from the beginning. That's what it does. The backend can decide to have completely different layouts for mobiles and tablets. So there would not be any change in the structure of the app. Like in how in Android you would probably have different layouts for landscape, different layouts for portraits and so on. You don't have to do that anymore. And again, you can build once and deploy changes anytime. More positives. A/B tests can be easily achieved. I think we already spoke about this in the first few slides. So the second one is a very interesting thing. It says you don't have to change your existing backend. So if you remember the first traditional way in which an API response was being sent to the client, you can still have the same services in your backend. What you need to do is you need to have some sort of aggregator service which is going to process that JSON into the actual JSON which we want. Okay, so you don't even have to change your backend anymore. You can just have another layer on top of your existing backend, which transforms your traditional API response to this type of component-based responses that that this approach would require. And of course, bug fixes can be pushed on the fly. And the next one is something which is again very interesting. It can make decisions based on the device capabilities and specification and serve specific functionality or UI. So think of a situation where a user is in a very remote place and say he does not have access to very fast internet. So you can somehow find out on your device that you're in a very low network area where the transfer of data is very slow. So you can basically communicate this information to the backend, and the backend can completely take a new decision saying, okay, this client is on a very low network area. So what we can do is we can send simpler UI to him. Since the backend has complete control over what needs to be displayed, it can completely ignore the fact or make use of the fact, in fact, to send data based on the device conditions as well, and capabilities. So what capabilities mean is, it means that, say, your camera, I mean, your phone does not have a very good camera. So we can completely, using this information, we can, the backend can decide not to show the camera feature to the user at all. So that's what it means, like based on every device, you can have decisions from the backend. Consistent UI and modularization, as I showed in the image example, once you have images of different variations, you'll probably be forced to use the same image again and again instead of creating one more image with size 36 or size 40. Since you already have a size 32, you can just use that everywhere throughout your app. Yeah, what are the not so positive? I mean, all this while it's been too good to believe. So the obvious one is each time you add a new element or a new action, we have to do an app release. So you saw the atoms, right? We had a button, we had a container, we had a list, and so on. Say tomorrow I need to add a new widget which Flutter introduces, say something like a sized box. So there is no way that we can use a sized box if we have not already created a sized box layout and drawable inside the app. So for that, we would have to do a new app release, and the same goes with actions. And then you have the hassle of versioning to maintain backward compatibility. Since this is completely driven from the backend, we need to make sure which version of the clients uses what sort of grammar. So if there are any grammar changes that we introduce, that is kind of tricky to handle on the client side. And of course, we need to maintain strict documentation for the grammar, since this grammar is what we built. It's not very easily understandable to anyone out there. So unless we have a very strict documentation, it would be very hard to onboard any new engineers to understand this part. And that's all, folks. And this is the credits that I had to, with due respect, give all the members to. It's basically the mobile engineering team at my company called ShareChat. I think we have around 3 minutes left. Questions, anyone? We have quite a few questions.
Can you show the full JSON for this request that is coming to the mobile app to create this little post?
Okay, the full JSON. So it would be inside this.
Yeah, but full with the all components. I just want to see how much data we will need to download.
Okay, I don't. So it would be something like this that you see. This is just one part of it, but if you want the full, it would be pretty large. It would basically contain all your resources, all your UI elements for that.
So we will need to download much more data than...
Yes, it would mean that much more data, but since this is all just strings that are being sent, it's not actually heavy, right?
Yeah, but 50 kilobytes and 200 kilobytes, it's a difference. So.
Right. So what happens in that case is since we are persisting all of it offline, and since I told you that the server can understand what has already been sent, it just sends a diff of what needs to be sent. So the next
time is awful.
Yeah, the first time you will have to load it. It's not awful. In fact, we have been live on the App Store for quite a while, and we don't see any problems with that. Since just think about it. Even though the first time is bad, the consequent times are much better than what we previously had, right? So that way we have sort of tackled usage of network as well.
Thank you.
Hello, thank you for presentation.
Yeah.
Just to make a continuation on previous questions. So I guess that you cache a lot of data locally on loading of the app.
Yes.
Basically on the landing page. So that means as a previous question was stated, that it takes longer time, but it may take more memory, local memory, which may result in slower or older devices to have a bit worse performance. So is there some limit that you put on your architecture that puts a hard cap on how many properties can be sent? Or something like
that. Okay. So to answer that question, we do have a persistent memory that we use. We use the Sembast database. So though there are some times that we have faced these memory issues, they're very rare. I wouldn't say it's been a problem for us. But since Sembast loads a lot of data in memory, we have to have some sort of a time limit after which, if the cache is exceeding some amount, then we would have to clear some parts of the data.
And also, do you have like a limit on those like more expensive widgets, such as, I don't know, Stream Builder or Future Builder, if you use it?
No, there's absolutely no limit on that, because at the end of the day, it's just another Flutter component, right? So we don't have any such limits. You can use them based on your requirements.
Okay, thank you.
Thank you. Okay, I think one last question.
I think we are
okay, out of time.
Out of time.
Okay,
so.
I'll be here around in case you want to get in touch or want to have some new ideas based on this. We can bounce off ideas offline as well. Thank you for your time.